The James Webb Space Telescope has opened a new window into the cosmos, revealing wonders we could only dream of before. It is giving us unprecedented glimpses into the universe's earliest moments, moments that shaped everything we see today. With its powerful instruments, we are seeing farther than ever before, pushing the boundaries of our knowledge. We are witnessing the birth of stars and galaxies in stunning detail, capturing the beauty of cosmic creation. The JWST's images are breathtaking, offering a visual feast for the eyes. They are also raising profound questions about our place in the universe. Could these discoveries offer evidence of a divine creator, or are they purely natural phenomena? The JWST's primary mission is to study the universe's origins, seeking answers to age-old questions. It is designed to peer back to the first stars and galaxies that formed after the Big Bang, illuminating our cosmic history. The data it collects is challenging our understanding of the universe, making us rethink what we know. It is pushing the boundaries of our scientific models, forcing us to adapt and evolve. The telescope's findings are sparking debate within the scientific community, igniting passionate discussions. Some scientists believe the JWST's images provide clues about the existence of God. Others remain skeptical, seeking more evidence. They believe natural explanations can account for the universe's complexity, relying on scientific principles. The JWST's discoveries are forcing us to confront fundamental questions about our existence. Where did we come from, and what is our place in the cosmos? How did the universe begin, and what triggered its creation? Are we alone in the vast expanse of space, or is there other life out there waiting to be discovered? One of the most startling discoveries made by the JWST is the presence of massive, complex galaxies in the early universe. These galaxies, which existed just a few 100 million years after the Big Bang, are far more developed than we ever imagined. The sheer size and complexity of these early galaxies have left scientists in awe and have sparked a wave of new research and theories. These galaxies are much larger and more developed than scientists had predicted. They contain a rich tapestry of stars, gas, and dust, forming intricate structures that rival those of much older galaxies in the present-day universe. They seem to defy our current understanding of how galaxies form and evolve. Traditional models suggest that galaxies should start small and grow over time through mergers and the gradual accumulation of matter. However, these early galaxies appear to have skipped several steps in this process. The existence of these early galaxies suggests the universe may be much older than we thought. If such massive and complex structures could form so soon after the Big Bang, it raises questions about the timeline of cosmic evolution. According to the prevailing scientific model, galaxies formed gradually over billions of years. This process involved small clouds of gas and dust slowly coalescing under the force of gravity, eventually forming stars and galaxies. They started as small clouds of gas and dust that slowly coalesced under the force of gravity. Over time, these clouds would form stars, which would then group together to form galaxies. However, the JWST's observations challenged this model. The telescope has revealed that massive galaxies existed much earlier in cosmic history than previously believed, suggesting that galaxy formation may have been a much more rapid and chaotic process. They show that massive galaxies existed much earlier in cosmic history than previously believed. These early galaxies are not only large, but also exhibit a level of complexity that is unexpected for their age. These galaxies appear to be fully formed and surprisingly mature. They possess well-defined structures, including spiral arms and central bulges, which are typically seen in much older galaxies. They possess well-defined structures, including spiral arms and central bulges. This level of organization suggests that the processes that lead to galaxy formation and evolution may be more efficient than previously thought. They are teeming with stars, many of which are much older than our own sun. The presence of these ancient stars indicates that star formation began very early in the universe's history, much earlier than our current models suggest. This discovery has profound implications for our understanding of the early universe. It suggests that the conditions in the early universe were conducive to rapid and efficient galaxy formation, challenging our current theories. It suggests that our current models of galaxy formation may be incomplete or even flawed. Scientists are now re-evaluating their theories and considering new models that can account for these unexpected findings. Some scientists believe these early galaxies could be evidence of a period of rapid cosmic evolution in the universe's infancy. This period may have been marked by intense star formation and galaxy mergers, leading to the rapid growth of these massive structures. This period would have been characterized by intense star formation and galaxy mergers. Such a dynamic and active early universe would have facilitated the rapid formation of large, complex galaxies, reshaping our understanding of cosmic history. The JWST's discoveries have reignited the debate over the origin of the universe. This powerful telescope, with its unprecedented ability to peer into the depths of space, has provided us with images and data that challenge long-held scientific and philosophical beliefs. The images captured by the JWST reveal the universe in its infancy, showing us galaxies and stars that formed billions of years ago. These observations have profound implications for our understanding of the cosmos. They provide ammunition for those who believe in a divine creator, suggesting that the universe's complexity and order are not the result of random chance, but of intentional design. One prominent voice in this camp is American philosopher William Lane Craig. Craig has long argued for the existence of God using philosophical reasoning and scientific evidence. Craig is a vocal proponent of the Kalam cosmological argument, a philosophical argument that seeks to demonstrate the necessity of a first cause for the universe. This argument posits that the universe must have had a beginning. It challenges the idea of an eternal universe, suggesting instead that the cosmos had a specific starting point in time. It states that whatever begins to exist has a cause. This principle is foundational to our understanding of the natural world and is supported by both philosophical reasoning and empirical evidence. The universe began to exist. This is a conclusion supported by the Big Bang theory, which posits that the universe expanded from an extremely hot and dense initial state. Therefore, the universe has a cause. This cause, according to Craig and other proponents of the Kalam cosmological argument, must be something beyond the physical universe. Craig argues that this cause must be something outside of space and time. It must be an uncaused, eternal entity that exists independently of the physical universe. It must be something uncaused and eternal God. This conclusion aligns with theistic beliefs about the nature of a divine creator. The JWST's observations of the early universe lend support to the Kalam cosmological argument. By showing that the universe had a beginning, these observations challenge the notion of an eternal, self-existent cosmos. They suggest that the universe did indeed have a beginning. This is a significant finding, as it aligns with the idea that the universe was created by an external cause. The discovery of these early galaxies challenges the notion of an eternal self-existent universe. It suggests that the universe is not infinite in age, but had a specific point of origin. The universe, as we understand it, had a starting point. This starting point is what the Big Bang theory describes, and it is supported by the data collected by the JWST. The findings of the JWST challenge the secular narrative of cosmic evolution. They suggest that the universe's origin may not be fully explained by naturalistic processes alone. They open the door to the possibility of a divine intelligence behind the universe's creation. This idea has profound implications for our understanding of the cosmos and our place within it. While the telescope's data does not constitute definitive proof of God's existence, it does raise intriguing questions about the nature of reality and the ultimate source of the cosmos. These questions invite us to explore the possibility that the universe is the product of a purposeful design rather than a series of random events. The idea of a divine creator is not new. It is a concept that has been woven into the fabric of human consciousness for millennia, transcending time and geography. It is a theme that runs through many cultures and religions throughout history. From the towering ziggurats of Mesopotamia to the sacred temples of India, the notion of a higher power orchestrating the cosmos is a common thread. From the ancient Egyptians to the indigenous tribes of the Americas, creation myths have sought to explain the origins of the universe and humanity's place within it. These stories are not just tales of the past, they are reflections of the human quest for understanding and meaning. These myths, often passed down through generations, offer a glimpse into the spiritual beliefs and cosmological understandings of our ancestors. Around campfires and in sacred spaces, elders would share these profound narratives, ensuring that the wisdom of the past was never lost. While they may differ in their details, many creation myths share some striking similarities. They often feature a primordial void or chaos, a state of nothingness from which everything began. This concept of an initial state of disorder is a recurring motif. They often speak of a primordial chaos from which order emerged. This chaos is sometimes depicted as a vast, turbulent ocean or a dark, formless void, symbolizing the unknown and the potential for creation. They describe a divine being or beings who shaped the world and breathed life into existence. These deities are often portrayed as powerful, wise, and benevolent, guiding the creation process with intention and care. Interestingly, some of these ancient creation myths resonate with modern scientific discoveries. The parallels between ancient narratives and contemporary cosmology are both fascinating and thought-provoking. For example, the ancient Egyptian creation myth tells of Atum, the self-created god who emerged from the primordial waters of none. Atum's emergence from the chaotic waters symbolizes the birth of order from disorder. Atum then created the world and everything in it through a series of emanations or utterances. Each act of creation was a deliberate and purposeful step towards bringing structure and life to the cosmos. This concept of a universe emerging from a state of formlessness bears a striking resemblance to the Big Bang theory. The idea that the universe began from a singular, dense point and expanded into the vast cosmos we see today is echoed in these ancient stories. The Big Bang theory describes the universe's beginning as an incredibly hot, dense point that rapidly expanded and cooled, eventually giving rise to the stars and galaxies we see today. This scientific explanation, while rooted in empirical evidence, shares a poetic resonance with the creation myths of old, reminding us that the quest to understand our origins is a timeless human endeavor.